Hi, my name is Pelumi Erota.
Hello, I'm Geoffrey Orji.
Hello, my name is Aishat Omolola.
Hi, I'm Eniola Olowokere.
Hi, I'm Damola Adedeji.
And this is Accounting Before Submission on Databases and Data Warehouses for the course Business Information Technology, FBA311. Every day, data is being generated. This data could be in several forms, from discrete, continuous, primary, and secondary. In as much, a lot of decisions also need to be made every day. So there's an inevitable need to understand databases and data warehouses thoroughly in order to ensure a smooth process of data retrieval. One major distinction between databases and data warehouses is that databases store data in real time, while data warehouses store just historical data. Another major distinction is that databases use online transactional processing system, while data warehouses use the online analytical processing system. What this means is that the latter needs a lot of analytical processes in order to make decisions. In this video, we'll be talking about data structures, database management systems, ethical and other considerations, as well as a case study. Stay tuned.
Okay, for this part of the presentation, we'll be looking at data structures. So data structures basically refer to the ways organizations can store and organize their information depending on their needs to make it easily retrievable and manipulated. So we'll be looking at three different types for this discourse: structured information, unstructured information, and semi-structured information. And to further explain, we'll be using a case study of a faculty office that keeps records of various students' information. So firstly, structured information. Structured information data structure refers to the data structure that links all parts of a file closely together. So these parts of the file are connected, they can be ranked, and they can be broken down into separate hierarchies. So there's a very close relationship between each part of the file. So using the case study, the faculty office, which incorporates structured information data structure, will have a single file which contains the records of all information from the students under separate fields like their names, their email addresses, their location, their ethnicities, their ages, and the courses they offer. So those parts of the file will be closely linked together. So whenever the organization needs to work on them, it can get them all at once. Secondly, we have unstructured. So for unstructured, there is no clear relationship or connection between the information on the data structure. So using the case study example of the faculty office, each student might just present a file which could even be physical and submit it to the faculty office. So this does not conglomerate all information from students. So they have separate, disconnected information, maybe stuck together in a cabinet or some sort of file. And the last is semi-structured information. Semi-structured information is right between structured information and unstructured information. Although there is no clear line joining information components together, there is still a bit of ranking that will be possible. So according to our case study, if a faculty office incorporates semi-structured information, it will just have individual folders containing details of the students, but these individual folders will be connected and linked together in one single folder. So although one file does not contain all information, it contains the various parts of the information submitted. Thank you.
So I'll be talking about database management software. The volume of data shared across enterprises are quite large and increase rapidly, thereby making data management difficult. A solution to this problem is database management software, DBMS. DBMS serves as a kind of gateway to the database itself and a manager for handling creation, performance, tuning, general maintenance, access rights, deletion, and backup. DBMS are software systems used to store, retrieve, run queries on data. They are used for creating and managing data in the database. Features of DBMS. 1. Data normalization. The risk of data duplication in a database is high as users share it simultaneously. DBMS makes data appear only once, and this is done through a normalization technique. With data normalization, data redundancy is therefore reduced. Another feature of DBMS is that it helps with backing of data. Backup protects the database against data loss. A copy of files stored in a database must be available to reconstruct data in case data gets lost or corrupted. DBMS therefore makes backing up data from a single location simple. The next feature is security protocols. One thing companies that handle a substantial volume of data are concerned about is security. DBMS protects the integrity of both database and the data residing in it. Its security control includes data encryption, user authentication, and user authorization. Now, let's look at the advantages of DBMS. It helps with better data sharing, it helps with better security, it helps in making informed decisions, it helps with effective data integration, and increase in efficiency and productivity. Next, I'll be listing few of the top database management software. We have a whole lot of softwares for data management, but for the purpose of this presentation, I'll be talking about just 3. The first is IBM DB2. These two support most of data science languages to handle simple and complex framework. It offers AI-dedicated capabilities that are able to manage and structure complex data. It is very easy to install and set up, and data is easily accessible. We can save huge amounts of data, almost up to bytes. The next is MySQL. MySQL is a high-speed data processing and data productivity tool with comprehensive features. The tool is designed to increase the security and scalability of databases. It is easy to learn the features without a programming background. It has a low-cost structure which makes it suited for small businesses. It works on both Linux and Windows. The third one is Cloudera. Cloudera is used by large corporations for higher data processing and optimal security reasons, which helps to improve their productivity. It has machine learning algorithms to understand and manage complex data structures. Now, we're going to be looking at how DBMS is applied to various industries. In the banking sector, database system is used to store clients' information, account activities, disbursements, credits, and mortgages. In telecommunications, database store call archives, monthly bills, retaining balances, and other related information. In human resource management, necessary information about employees, assessments, deductions, tax records, salary slips, etc. are stored in DBMS. In the education sector, information about student registration, their results, courses are accumulated in database system and is retrieved with the help of database admin. That is all. Thank you.
Do you ever get a niggling feeling that you are being followed, that your conversations are being overheard, and your footsteps are being followed, your data is being collected? In the physical space, this might be a kind of stalky behavior, but in the digital space, we have our data being collected every time, and sometimes we don't even notice. Data ethics covers the moral responsibility of collecting, safeguarding, and using personally identifiable information, as well as how it affects people. There are 5 principles of data ethics. We have ownership, transparency, privacy, intention, and outcomes. Ownership. The first thing you have to know if you're going to be collecting data is that every individual, they have a right to own their own data. If you take their data without their knowledge, it means that you're stealing from them. Then transparency. You have to be transparent about whatever you are going to use their data for and why or how you want to collect them. It is advised that entities have a data policy that shows how they are going to collect user data or whatever they are going to use it for. Then another thing to ensure is the privacy of the participants in your data collection. You have to ensure that their personally identifiable information are kept private and secure, and there is nothing that can link it to them. Then your intention is very important when you want to collect user data. You have to make sure that your intentions, they are not malicious and they are for the right reasons. Then the outcomes of your data collection and whatever you use their data for must not have negative impacts on them. It must not come back to down the participants of the data. If we take a case study on Google, a 2018 report says that Google has the ability to, even when users of Google turn off their location, Google has the ability to still pinpoint and timestamp their location using other apps such as Google Maps, Google Weather, and even the web browser. So what exactly does Google use this data for? Google argues that these services, they are opt-in services, and users can still turn them off whenever they like. So if users can turn off these services, can we actually say that users are giving consent to have their data being recorded? And do we know what exactly Google is using this data for? Are they transparent about it? Do they give this data to other corporations? And if they give this data to other corporations, what do these corporations use this data for? So these are all the questions that are surrounding data ethics. Is Google being ethical with their collection of data?
What is data warehouse? Data warehouse can be defined as a central data repository containing information drawn from multiple sources and that can be used for analysis, information gathering, and strategic planning. An example of data warehouse can be a couple of internal and external data. Internal data can include operational data, customer data, and even archived historical data. While external data includes sensors data, competitors information, and GPS coordinates. All these will need to pass through a process known as the ETL, which stands for extract, transform, and load. This is because data gathered will not be in the format of the organization's own data structure, so it would have to be transformed. Big data. The term big data means collection of data that are so large in size, vary in content, and even accumulate so quickly that they are difficult to store and analyze using traditional approaches. Nonetheless, big data is accompanied with three characteristics. First is volume, second is velocity, and third is variety. Volume is how much petabytes of storage data collection can take up, while velocity is about how data storage change and grow at very fast speeds. Similarly, variety relates to different nature of data. Big data technologies. In recent times, there have been a number of new technologies under development to handle big data better. Examples of these technologies are NoSQL, Hadoop, etc. Challenges of information management, the human element. Some of these issues are ownership issues, database without boundaries, and even balancing stakeholders' information needs. Thank you.
Now, we're going to be talking about a case study on databases and data warehouses. The days of chasing traffic offenders are now behind us, especially in Lagos State. Prior to now, vehicle drivers could get away with fines for offences such as incorrect registrations, untimely license renewals, defying traffic signs and stops, and so on. The introduction of the PayVis, a number plate detection platform by the Lagos State government, and an automatic number plate recognition device have tremendously helped with the aforementioned. This only emphasizes the powerful use of databases in road and traffic management. To facilitate efficient tracking, the databases of cars, license registrations, parking tickets, and even roadworthiness must be maintained. Therefore, when motorists commit traffic offenses, the high-definition cameras placed at strategic locations capture and retrieve the respective motorist information for traffic officials to make appropriate decisions. This automated high-speed system reveals the importance of database management to eventually increase the chances of longevity among many other things. In summary, in this video, we've talked about the different types of database management systems we have, ethical considerations, including big data, as well as a case study. We hope that you are more enlightened. Don't forget to like, subscribe, and share. Thank you very much.